Okay, well, let's start. Excellent. Wow, no one told me so many people come to tutorials at PyCon. So, excellent, excellent. Welcome, everyone. My name is Reuven. Just a word or two about who I am, what I do, and then we'll jump right into things. So, I have been freelancing since 1995. I've been using Python for about 30 years now, and nowadays I'm a full-time Python trainer. So I work with companies all around the world, individuals all around the world, helping them to improve their Python skills. I do a lot of corporate training, I have a lot of videos, I have all sorts of stuff, and I'll even have a booth here at PyCon so you can come by and talk to me more and hear more about stuff, and get t-shirts because you are coders, and all coders need more t-shirts, or so I tell my family. So, what are we going to be talking about today? We're going to be talking about comprehensions. And I must say, comprehensions are, at once, one of the things that I most love using and teaching about. They're also one of the things that are incredibly mysterious, off-putting, frustrating, on and on. A number of years ago, I was interviewed on a podcast, and the two hosts of the podcast asked me, so what is the hardest thing for people when I'm teaching them Python? I said, oh, hands down, it's comprehensions. And both the hosts said, oh yeah, we don't quite get them either. So it is a very, very widespread frustration. And many people are like, well, you don't need them, I'll just use a regular for loop. Or they're just confusing, or on and on and on. And what I'm hoping that you're going to find today is that comprehensions are, to use the phrase, comprehensible, they are understandable, and they're even desirable in many, many cases. And they're definitely part of idiomatic Python. And so I'm going to be going through a lot of demonstrations here. I'll explain to you in a moment how I teach. We're going to be doing a lot of exercises, and I'm very, very, very much hoping that if you are frustrated, confused, things aren't working for you in the exercise, or you don't get what I'm saying, that you will tell me. My job is to make sure that you understand what's going on. And so if you leave here not understanding, then I haven't done my job well. And so also the odds are staggeringly high that if you have a question, someone else has the same question. And so you will be doing them a favor if you ask the question, because otherwise the two of you are like, well, I don't want to embarrass myself. So if you want, you can just raise your hand and I'll call on you, and you can say your question, I'll repeat it here. If you have a long, complex question, I won't repeat it well because we'll be paying Python telephone. You can get up to the microphone. I like my classes to be super interactive. I don't just like lecturing, although my children would perhaps disagree with that. I definitely want this to be a lot of give and take, a lot of what ifs, a lot of sort of bringing up your own experiences. Now, the other thing is I don't use slides when I teach. Instead, I use Jupyter. I think I sent email about this. I hope I sent email about this. And so basically here, I'm going to show you, this is my Jupyter notebook. I've enlarged it so I have this screen here. Fantastic. Wow, it's like they thought of everything. I'm going to make this a little smaller so it doesn't seem so ridiculously comical. I hope that those of you in the back can see this. If not, I guess that will be the first question, right? And so I'm going to be typing into Jupyter, live coding, both some documentation and a lot of code. And this is uploaded to GitHub on a regular basis, about once every minute or two. In fact, let me just turn on autosave 30, so it'll be even faster than that. And so that GitHub repo will be available to you while we are here. And if you go to GitHub, and I'm at github.com/Reuven, spelled the way it's pronounced, haha. All right, I can put this here as well. So, GitHub repo for this course. And I'm using something called Git Auto Push. And so as I said, minute or so, whatever I do will be pushed up there, and you can look at it. And you can look at it after the tutorial is done as well, if you want to refresh your memory or are having trouble falling asleep at night. We will be using some files that I put in that GitHub repo as well. I also sent you a link where you can download them. I think I made them downloadable via the platform that we're using for PyCon. We're not going to use all those files, but we are going to use some of them, and the idea is basically that we're going to be using some files for things, so it would be useful to have them, right? Okay, so let's do a little agenda here. So the first thing is, what are comprehensions, right? And then we're going to talk about list comprehensions. We're going to talk that, and we're going to do that for quite a while. We're going to talk about list comprehensions and files. We are going to then talk about set comprehensions, and we're going to talk about dict comprehensions. The word comprehensions is going to come up a lot today. Then we're going to talk about nested comprehensions, and finally we will talk about generator expressions. These last two topics we're going to cover relatively briefly. Also, like the way I teach, it's often a lot of flexibility here in terms of time. But don't worry, we will get to everything and we will practice everything. and we will get to your questions. And if I have to stay a little bit later and answer your questions, that is okay too. The only rule is that there is a break at 3 with food, and if I stop you from getting to that, then there will be no second half of this tutorial because I will be a rotting corpse after you have dealt with it for not getting to your food. So I recognize there are important constraints in the universe. Okay, so let's start talking about what is a comprehension. And let's say, and I know this is going to be very similar to the work that you all do day after day. Let's say I have a list of numbers, of integers, and I want to create a list of those integers to, squared to the second power. Right? That's what you do all day? That's what it's like in big companies, I know. So how am I going to do this? Well, I can say here numbers equals, I'll just say it's a range. Actually, I'll make it a list. Not that it matters that much, but I have to stick true to the documentation. Otherwise, at the next meeting, they'll get me. And then we can look at numbers here, and sure enough, that's a list of 10 numbers. And I can say then, well, I'll create output as an empty list, and I'll say for one number in numbers. I'll say output append one number to the second power. And sure enough, wow, amazing, the next IPO in tech is waiting right here in Salt Lake City. So what is going on here? Well, I'm creating a list, output equals empty list, and then I go through it one element at a time, and each of those elements is then squared, and we append that to output, and so our list is growing and growing and growing over time. And sure enough, then we get that output. Fantastic. And this is where I say, as I so like to, unfortunately, this works. You absolutely positively do get the right answer in doing this way. And an awful lot of Python developers will say, it's so obvious, it's so straightforward, why not just stick with this syntax? To which experienced Python people are like, oh my God, another person I've got to convince this of. No. It's natural that you want to stick with things that are familiar and less sort of daunting. So what is another way to do this? Well, it's going to be a list comprehension. And so here's what I'm going to do. I'm going to take that same code, and I'm going to rewrite as a comprehension. I'm going to run it to prove to you that it actually works. And then we're going to go through it and talk about what it's doing and how it's doing it and what it's not doing. So I'm going to say here, let's start by spelling it right, one number to the second power for one number in numbers. First of all, it works. Second of all, writing code like this guarantees me job security because no one else will ever be able to understand what I'm doing, and they'll have to keep me around. But what is actually going on here? This is, of course, a list comprehension. And it's much easier to write and understand if we pick it apart and write it on multiple lines. And you might be saying, wait, how can we do that, right? Python is so persnickety about how we do indentation. That is true, except when we've opened parentheses, because the moment you open parentheses, then Python's like, oh yeah, that's part of the same line, we're just going to sort of ignore it. So I'm going to put these on two separate lines. And once I do that, first of all, from my perspective, it becomes much, much more obvious what's going on. And second of all, now we can start to reason about what it's doing. And I'll tell you, the moment that I started writing my list comprehensions on multiple lines, things got way easier for me and for the participants in my courses. This was probably, 10 years ago, something like that. And I remember, I have a very, very, very low score on Stack Overflow, in part because, years ago, I posted something about list comprehensions, and I posted it using this kind of syntax, and someone was like, that's ridiculous, that's terrible, and I was so put off, I was like, I'm never coming back to this site. All right, which was a lie, but fine, we need somewhere to copy and paste from. In any event, what's actually going on here? So the first thing you want to understand is that there are two parts to this comprehension. We're going to grow that over time, but there are two basic parts. And the first part here is what I call the expression. And this can be any Python expression at all, which means any function call, any method call, any operator, anything at all that returns a value. That last part is kind of important. And if you're not familiar with the whole idea of what is an expression in Python, it's something that gives me back a value. So it could just be a plain old variable. It could be calling a function or method on that variable. It could be the interaction among several variables, whatever. But whatever that expression gives back, that's what we're going to have. And then here is the iteration, any Python loop. And once again, this works. And many people look at this and they say, oh, I get it. A comprehension is just a really, really short for loop. It's like a compact way of writing a for loop. And that's sort of true, but it's mostly not true. Because, and here's the big distinction. Well, actually, we'll get to the distinction a little bit. Let's talk through a little more here. So one of the things that's frustrating for people is that comprehensions seem to run backwards. So in a comprehension, the first thing that runs is the loop. And the second thing is the expression. So it's like written backwards, and that's very sort of surprising to many people. And so what's happening here is our for loop is running just like a regular for loop, well, mostly like a regular for loop. And so we're going to iterate over numbers, and so it has to be iterable. Numbers is a list, it's iterable. So the for loop says to numbers, are you iterable? Yes, so give me your next thing. The next thing is put into one number, and then we get our expression back, and then we go to the next thing. Here's the thing, at least the way that I've written the comprehension here, we will have, so the result of a list comprehension is a list. We have created a new list, and we can pass it as an argument to a function, or assign it to a variable, or just enjoy its exquisite beauty. I don't know. We can do whatever we can do with a list. This is a new list. It is completely unconnected to the previous list. And the new list is the result of evaluating our expression on every element of the input. Input we'll call a list. So basically what's happening, every single element of numbers is passing through that expression. And whatever the result of that expression is, that's what is put in the output list. So as a result, the output list will have the same number of elements as the input list. So here, numbers is 10 elements, 10 numbers. The output from this, which I haven't named here, I'm just seeing it in Jupyter, the output is also 10 elements. And each of those elements, you can think of it as mapping one to the other. So the 0 index is 0, kind of appropriate, and then the output is also going to be 0, because 0 squared is 0. All right, let's go past 1. Right? So at index 0, 1, 2, we've got the number 2, and that squared is 4. So we can see them as two parallel lists, the input and the output, where the difference between them is the expression. You can sort of kind of think of this as working with a spreadsheet in Excel, right, where you've got a column of numbers, and you apply some expression to all of those numbers, and then you paste it into a column next to that. That's kind of what we're doing here in our comprehension. Now, the fact that so many things in Python are iterable, and that we have more or less an infinite number of expressions, means that list comprehensions are huge, right? We can use them in all sorts of places. But let's back up for a moment. Why? Why would I use them? What is the advantage of using a list comprehension rather than just using a regular old for loop? Like, if it's going to frustrate people, right, which is good for the tutorial business, but bad for humanity in general, then maybe we should just stick with regular for loops. And the distinction is basically one of what do you want to do with things, right? So when use a loop and when a comprehension. And so basically, the big distinction is between getting a new value back and having side effects. Meaning, if you have, can't type today, you have an existing list, and you want a new list, and you can describe the sort of mapping from the first to the second, then you should use a comprehension. And the idea is, I want to get that list back, right? I want the list. I want the list. But if you are assigning repeatedly, if you are modifying things repeatedly, then use a regular for loop. That's the big distinction. Am I doing it for the side effects of what I assign and change and mutate, or am I doing it to get a list back? Now, when you start off with comprehensions, these two ideas seem almost completely like the same. It takes time. It takes years of using comprehensions to slowly but surely see when you would use one versus the other. Right? It's not a super, super obvious distinction. And again, the fact is you can use a regular for loop in many cases. Now, I'll tell you the other reason to use comprehensions, which is the bad reason. And the bad reason is that it is more efficient. Now, why is that the bad reason? Because it's not always more efficient. It's not always hugely more efficient, right? When I teach people who come from a C background, they're like, oh, well, that's why I'm going to use it, right? I must use the thing that's faster. Okay, calm down, C people. Yes, we do want it to be faster, but that's not our ultimate goal in Python. Here, the idea is that semantically it's expressing something more powerfully and more compactly. And you're going to see as today goes on that we can do very, very sophisticated things with comprehensions if we want to. Okay, so let me show you some more sort of useful examples, right? So let's do this. What if I say here, for example, let's say that I have a list of strings. So I'm going to say here S equals, my list equals A, B, C, D, E, F, G, H, I. And I want to have a new string based on my list with stars between the elements. Okay, well, as you might know, I can say star.join of my list. Fantastic, that worked just great, right? So the join method, rather counterintuitively for many people, we invoke it on what I call the glue, right? The string that's going to go between the elements, and we pass the argument of my list, and fantastic, we get back this string. But what if I have a list of integers? So if I say my list equals 10, 20, 30, and now I say star join of my list, bad news, we get an error. And the reason is that join expects its argument to be an iterable of strings. You can pass it whatever you want, a string, a list, a tuple, whatever, but the things that it's going to iterate over have to be strings. So we have a list of integers. We want a list of strings, and we can convert one int to one string with stir. So I can say, open square brackets, stir of one item for one item in my list. And sure enough, I get back a list of strings. Have I modified my list? No. Have I assigned this anywhere? No. But I can if I want to. I've created a new list and I can do something with it. For example, I could say here, star.join of, that whole thing, stir of one item for one item in my list. And there we go, now it worked. I did not change the original list, but I got back a new list based on it that join was okay with. And this is a classic sort of example of where we're going to use a comprehension, that I have some iterable, I want to do some transformation on each element, and the comprehension allows me to do that. Some of you might be familiar with, either in Python or other languages, with the map function. And the map function does basically this. In fact, Python has map and it has filter. And we're going to see in a little bit where filter fits into this whole puzzle. But basically nowadays people don't use map and people don't use filter because we have list comprehensions. They basically obviated the need for those built-ins, even though they do still exist. And this is definitely considered to be the modern idiomatic way to do this sort of thing. Let me show you one more example. So let's say I have a string and I want to capitalize each, the start of each word. Well, if I say let's do this, this is a sample sentence for my tutorial. So I can say s.title. Ta-da! And the title method is a string method, and it returns a new string, right? Can't modify the original string because strings are immutable. And I get back a new string where each and every word, the first letter is capitalized and the rest of the letters are lowercase. So what if stir.title didn't exist? Could I still do something like this? And the answer is, of course I can. It's Python. So what if, for example, I were to break the string into individual words? Then I have a list of strings. I want a list of strings whose first letters are capitalized. I can use stir.capitalize, not to be confused with stir.title. Stir.capitalize, which capitalizes the first letter and makes all the rest lowercase. So if I now say s.capitalize, let's do one word dot capitalize for one word in s.split. And look at that. So I used split, I got back a list of strings, and because I didn't specify any argument, so it uses any white space, any combination of white space. And so I got back a list of strings, and we iterate over that list of strings. Each string then we run one word.capitalize on, we get back that list. Well, that's fantastic, but wouldn't I like to see it put back together? Well, I'm sorry, putting back together is more advanced. I have to say then space.join of this whole thing. And look at that. And so many, many times, the way that we use comprehensions is that we start with something big, we break it apart. Thanks. You just put it here, I'll have it later. Or put it in the back, thanks. Sorry, there was a whole mix-up with kosher food earlier. Very exciting, I can bore you to tears with it later on. In any event, so I'm going to split things up, break things apart, apply my expression to each element, and then I'll mush it all back together. So split and join, when you're working with comprehensions, are like your best friends. All the time. Can I use functions that I've written? Yeah. Can I use methods that I've written on classes? Yes, absolutely. There is no limit to what expressions we can use and what we can iterate over. All right, let me stop here. Any questions, confusion, so on and so forth? Yeah, please. Yes. They are, especially as they get bigger, they are definitely more performant than for loops, but every time I demonstrate this, I discover that they're not in my little examples. So I'm not going to take that risk and let everyone know. Right, exactly. I use time it, and I'm like, look, it's, oh no. So you need something a little bigger than I show people, but yeah. The other thing, and I think I wrote something about this on Twitter a while ago, I've got to write more about it, but in a list comprehension, it has its own scope because there's a little function hidden inside of there. So any variables you define, like this one word, does not leak out. So it's not going to affect your global scope. If that sounded like gobbledygook to you, ignore it. It is not that important. If that was like, oh, wow, scoping, then yeah, you're my kind of people. Anyway, other questions? Okay, so let's do some exercises to practice with this and try it out. Oops, there we go. So what I want to do is, first of all, ask the user to enter a string containing numbers separated by spaces, and then add those numbers together, right, as integers, and print the result. Okay? And it's okay to use the built-in sum function, right? And the second thing is ask the user to enter a string and print the length of the string except for white space. All right? And it's not okay to use stir replace. There's always someone, always someone. All right, so I'll give you folks a few minutes to work on this. If you have questions, problems, whatever, I'm happy to come over to you and take a look at whatever's going on. All right, so we'll give, I'm sorry, what? Oh, how many numbers? 5. You fail the tutorial if you do it with 4. By the way, obviously everyone here is at a different level of Python, and so people are going to know different sort of tricks and tips and methods and functions. So if you find yourself like, oh, I don't know what's going on, or like if you need some help, it's okay. I can help you. Not that school should be that way, but like this is not school. I'm happy to help. Okay, let's start to look at this together. So, like exercise 1 here. So I'm going to say s equals, I can say input, enter a string, or enter numbers separated by white space. Do a strip there, right? So I'll do like, 10, 20, 30, 40, 45. Whew, what a rebel. All right, so I have s here, and this is a string. So what if I try to say sum of s? That will obviously not work at all. And that's because sum looks at this thing that it got, and it actually tries to iterate over it. It's like, wait. I'm trying to start with 0, and I'm trying to add to that, and I can't add a string there. So we have this problem now where we've got an iterable of strings. So what I have is a string, and what I want is the sum of the integers in that string. Maybe I should start off with something different, right? Maybe I should do a list of strings, and then, right, containing digits. And so how can I do that? I can transform one to the other with int. So I can say here, for example, one item, the int of one item, for one item in split. And look at that, it's a list of integers. So now I can say sum of int one item for one item in split. There we go. It added them together just fine. Because what's going on? Right, sum never sees our list of strings. As far as it's concerned, sum is getting a list of integers as its input. And so we're able to sort of mediate between the two of them. Okay, questions about this one at all? Yeah, please. Because, well, I mean, I didn't define items. I could say items equals split. Okay, excellent question. Watch this. What if I were to say here, sum of int of one item, right, for one item in S? Yeah, so it's going to go very poorly. Why? What's going on? What's the problem? Well, it turns out that I had spaces between my numbers here. So 10 space, so it was going to add 1, so far so good. 0, so far so good. Space, kablooey. Now, that is a totally legitimate other thing. Like, sometimes I give that as an exercise, too. Okay? That's fine. No, that's fine. Everyone in all software always pays attention to all specifications, so it's never an issue. Yeah, someone had a question back there? No? Any other questions? Okay. So let's look at the second one here. Oh, and I'll try to remember to repeat the questions that people are asking because the video is not getting them. I'm sorry about that, people on video. You should be here with us. Okay. So now the second thing that I said was, find the lengths of the words, not the white space, in the user's input. So if I say s equals input, enter a sentence. Just strip. Right? And then what I want to do is I want to know how, well, I can find out, like, len of s, right? How many characters in the entire sentence. So if I say, like, this is a test sentence, it's going to say 23, which is true, but that's not what I wanted, right? How long is this if we ignore the white space? So what I'm going to do is, if I use s.split, I get a list of strings without any white space. And then I have a list of strings. I want the sum of their lengths, right? And I can apply len. So if I now say, for example, one word for one word in split, let's just get the sentence there, okay? This is a test sentence. Now I can say len of one word, not lenum, one word. Now I have a list of integers. And now what I can do is I can say sum of this whole business, and there we go. And I get the sum of the lengths of the words without the white space. And again, it's this sort of breaking down and building back up that's key to using comprehensions. You're thinking about what can I do for each of these little pieces. Okay. Questions about this? Comments? Yeah, please. Oh, so the question is, why did strip take away the white spaces from the count? Oh, why didn't it? Oh, I see. So you're asking, like, my original strip back when I got input, right? So when I did strip here, shouldn't that have taken care of the white space? And the answer is, as always with me, yes and no. So strip removes all the white space from either side of a string, but does not touch the white space inside of the string. So if I say, for example, like, s equals A, B, C, and I say s dot strip, it'll still leave the white space inside. Okay? So the question is, split automatically splits by space, and the answer is, once again, yes and no. If you split without any argument, then it will take any white space character, which is space, character turn, tab, new line, and my favorite, vertical tab. So any one or more of those together are all considered one space, and those get out, and that's where we cut. So yes, it's spaces, but it's more. It's space plus. And so basically, if you want to split a sentence into words, then not giving an argument to split is just super, super easy. Any other questions so far? All right. Let me go back to this for a moment here. Let me go back to one of the previous comprehensions just to sort of show you one other way to think about this. So I'm going to just grab this just because I can. All right. So what I have here is, of course, what I said before, my two lines, and I call this first one the expression and the second one the iteration. There is another way to think about this, and that is if you know SQL. This is a lot like select, and this is a lot like from. Now, if you don't know SQL, now I've confused you twice as much, but if you do, then this is like exactly the same sort of mindset. And just as with select in SQL, I can apply all sorts of different functions, methods. I just want an expression. And if I use from, well, it's from any iterable. And basically everything in Python is iterable, so that's great. Oh, well, okay, so this S-split didn't really do what we wanted, but fine, doesn't matter. Right, if I say here S equals 10, 20, 30, now it won't blow up. There we go. Let me show you one more thing, one very, very common mistake that people make with comprehensions. So let's say, so I have a string with words, and I want to print each word with stars around it. It's like we're moving to Hollywood or something, right? So if I say S equals, this is fantastic. And so I'm going to say here, right, I'm going to say print star one word. I'm going to use an F string here for one word in S split. So what's going to happen here? Well, I'm splitting S. I'm going to get back a list of strings. I'm going to go through that list one element at a time, and then I'm going to print it out. Fantastic, right? Sort of. See, this is why I always say yes and no. It did print what we wanted, but what the heck? None, none, none. So you have to remember that the list that we get back from a comprehension contains the values that the expression returned. And print always returns none, no matter what you print. So here, it printed on the screen, but it returned none, which affected our output comprehension rather dramatically. And so you basically never, ever want to use print inside of a comprehension. Right? It's just like a bad idea, and yet I see people do it all the time. Okay. So we can iterate inside of our comprehensions over strings, lists, tuples, dictionaries, right? You want to do that, you can totally do that as well. All that's fine. But there's another thing that we can do. How about iterating over files? Well, files are iterable. And I'm using the term file, even though technically speaking, we should say file-like objects in modern Python. But come on, who says that? We all just say files, and we all we all just sort of roll our eyes at the documentation. So how about iterating over files? Can I do that? Well, sure. I can say here one line for one line in open, and here I'm going to use one of the files that I gave to you. Here, let's see, what do I have here in this direction? Oh, fine. I'll just say, I'll say Linux etc password txt. So what happens here? I get a list of strings back, right? So what's going on? Open returns a new file object, an open file for reading. The for loop inside the comprehension turns to that file and says, are you iterable? The answer is, yes, I am. So it says, okay, give me your next thing, your next thing, your next thing. And the way the files work is with every iteration, we get up to and including the next new line character, that \n. The result is then that we have created a list of strings where each string is one line from that file. Now, I should warn you, if the file is really big, this will not end well, right? If you decide to do this with a 2 terabyte file, well, it could end well. Your IT department might give you the upgrade you've always been asking for. However, that seems unlikely, and so you should try to avoid doing this with big files. But small files, medium-sized files, it's fantastic. Well, wait a second. Maybe I can do some interesting things with a file, like if I'm already opening it. Right, so what if, right, can I get the usernames from this password file? And for those of you unfamiliar with it, this is a kind of file that's available on all Unix systems, Unix, Linux, Mac, and so forth, and originally contained usernames and passwords. Someone then realized perhaps having the passwords right there in the file was not such a smart idea. It might be used by bad people somewhere. And so you can see now that in the second field here, so each of these are records, and the second field here used to have a password, now it just has X's and the passwords are elsewhere. And a lot of systems, they don't even use this anymore, on and on. But they're great files for practicing working with files in Python. So here's what I want to do. On each of these records, we can see that the fields are separated with colons. Can I grab all the usernames from this file? Maybe. Right, so the usernames are, so each record contains fields, and the first field, fields are separated by colons, and the first field is the username. So what if I were to say here, one line split colon 0 for one line in open Linux password txt. So I'm going to open the file, I'm going to go over each line, and each line I'm then going to split it into a list on colons, and I'm going to grab the first element from that resulting list. And there's good news and bad news. The good news is that I did indeed get a list of strings, and those strings are basically usernames. The bad news is that this file also contains things that are not usernames. And in case you think that this is just completely contrived, there's a small company called Apple that puts comments in its password files. And I am so thankful that they provide me with these pedagogical opportunities in between all of their other things that they do as a business. So you will have files with all sorts of weird stuff that you've got to get rid of and ignore and so on and so forth. How do you do that? Because everything I've told you until now says that the number of elements in the input and the number of elements in the output have to be identical. So what am I supposed to do? What's a guy supposed to do? And the answer is we make things more complicated. That's right, because we're programmers. So basically, it is true that I have two parts to my comprehension. The first part is going to be the expression, sort of like select. The second part is going to be the iteration, sort of like where. And that's right, not where, it's going to be from. Jumping the gun already. Right, and the third part, on the third line, is going to be the condition where. And this is where things start to get complex because we're going to end up jumping around a little bit. And so I can say, for example, if, let's just say like colon in one line. So if there is a colon there, then we're going to assume it's okay. I think this will work. Now, how the heck does this work? The first thing to execute is the for loop, as before. All right? And for every single element, for every value of one line, we then go to this if. And if that is true, if the condition is true, then and only then do we go to the first line and produce output and evaluate our expression. Meaning the expression will not be evaluated all the time, only if the condition is true. What can I put in that condition? Anything I want. Anything that returns true or false, or anything that's like truish in a Boolean context in Python, totally okay to put there. And so you can make it simple, you can make it complex. Don't make it complex, but you can. And so this combination of three things, of the expression, of the iteration of the condition, or if you prefer, select from and where, databases have had a pretty good run using this kind of query language. And it's no surprise that the comprehensions are similarly powerful and, believe it or not, popular in Python because they allow us that same kind of power. And now the number of lines in the output doesn't have to be the same as the number of lines in the input. It can be the same or fewer. All right, questions until here? Yeah, please. So the question is there also a possibility of putting an else? And the answer is not really. There is a version of if-else in Python that is designed for this kind of place where you want to make things conditional. And I find it so horrible to use, let alone explain, that I basically tell people it doesn't exist unless they really press me. But it's meant for this kind of place where you're sort of stuck. But don't do it. Yeah. Other questions? Yeah, please.
So you're describing this as select from where. To what degree does that pattern from SQL actually inform the design of the implementation of comprehensions? Were they trying to do that, or is that just your interpretation, your view of how you can think of it?
It's just me, for better or worse.
They weren't trying to mimic that pattern when they implemented comprehensions.
So my impression, and I haven't really checked into this super fully, is that Python was not the first language with comprehensions, that they came from elsewhere. And I would not be surprised if all that stems back to some similar theory of queries that like has a common ancestor. But where, how, I don't know. I will say, like, the moment I sort of stumbled on this, I was like, oh my God, like this makes like, and the more I talk to people, like, again, it doesn't help everyone, but it helps some subset of the population where they know, okay, well, yes, please. Oh, so the question is, are there places where we would use Lambda instead of this? So Lambda allows you to create anonymous functions, and it goes hand in hand with map and filter, which are kind of the predecessors to list comprehensions. And I think one of the motivating factors, again, I'm not sure, but one of the motivating factors behind comprehensions was to dump Lambda as much as possible. That get rid of the word Lambda, which confuses people, get rid of the argument, the parameter there, and just use the body of the Lambda, which is what we've got here effectively. I would say Lambda is like increasingly passé in the Python world, except in the pandas world where they're like having a Lambda party every day. But people are trying to avoid it because of this. Yeah, if you're using Lambda and pandas, you're in good company. A lot of people are doing that. But it's basically, as far as I can tell, only in pandas. Okay, so let's play with this a little bit. Let's do a little exercise. So I have here a file called nums.txt, which contains numbers. And so basically, let's do this, exercise, some numbers. Excuse me. So basically, I want you to use a comprehension to read through nums.txt and sum the numbers it contains. Each line of the file contains either 0 integers or 1 integer. There's no way that there's going to be more than that. And the integer might well have white space before or after it. All right? So see what you can do to play with this. And we'll go over it together in a few minutes and then look at all sorts of additional stuff. And again, if you have questions, feel free. Okay, so let's look at this together. And I'll admit, this is one of those exercises that's really, really short and really, really annoying. Well, for the people who have to do it. I'm fine with it. So let's do this. I'm going to say here, I have, a file whose lines contain numbers, right? And I want basically a list of numbers, a list of integers, right? So, I can transform from the string, whose lines, which will be strings. So I can transform from a string to an int with int. So I could naively say one line for one line in open nums.txt. Well, that'll give me the lines, and we can see it's a horrible mess there with new lines and tabs and spaces. So I could say one line.strip. I could, by the way, int does that for us automatically, but fine. And we see, okay, there's a blank line there. And what if I say int here? And that's where it blows up. And it blows up because it turns out, here's fun facts for you. If I say int of 5, that gives me 5. Hopefully not too surprising. If I say int of 5, that's also fine. But if I say int of spaces, that blows up, or int of an empty string. So it's totally fine as long as I have something in there that can be an integer. But giving it an empty string, not good. And that's exactly what we're doing here, right? We even saw this before. When I didn't have the int, we saw that line was stripped down to just be an empty string. So luckily for us, we have conditions. Right? So what I can do is I can implement my condition here, add a condition. Now, what kind of condition will I add? And there are a whole bunch of different things we could do. One would be to say, like, if one line strip. Right? So here, just check that the line isn't empty. Because an empty string returns false in a Boolean context. Any other string returns true. So assuming we're willing to believe the people writing the specifications that if there is something on that line that it is an integer, then this will work just fine. And sure enough, that works great. We get our list of integers, and then I can run sum on this sucker, and it's great. Right? If I want to be a little more cautious, then I could, do that. In fact, I can get rid of the strip here when I do int, because it's going to do that automatically for me. And do I have the right number? Yeah. Okay, that works fine. So here I could say int of one line, so that stays the same. Good. And here I could say, like, if one line strip is digit. Right, and is digit basically says, it's a string method, does this string only contain digits 0 through 9, nothing else? And if it passes that, then we're totally fine. It won't work on negative numbers because it doesn't allow for negative numbers, but let's not be so negative. Ha, ha, ha. Okay. So the question is, what is the first condition doing if one line dot strip? So it's taking one line, it's taking the current line, it's removing any white space that might be on its edges, again, not in the middle, and then it's returning a string, and if looks to its right, and it requires a true or false value. It won't accept a string. So it says, hey string, are you true or are you false? Are you truish or false-ish? And basically every string in Python is true in that context except for the empty string. So the only way that if will be false is if we have an empty string, meaning if the line only contained white space, then that line will return false, and then we will not try to run int on it. So this is a safeguard to make sure that we're not trying to call int on an empty string or just a white space only string. Other questions about this? Okay. So let me show you like one or two other examples of cool things we can do with this, and then we'll even like do something a little more exciting. Well, meaning difficult. So what if I want to know how many vowels are in a word or in a string? Right, so how can I use a comprehension for that? So if I say like s equals, whatever. So I could say here, well, how would I use a comprehension? Well, how about this? What if my expression is 1 for one letter, let's say one character, in S, and we say if one character in AIOU. And so I'm going to get 3 ones. Right? So now I can just say sum this up. And there we go. We find out there are 3. And you will definitely find places where people do this kind of thing in Python, where the expression turns out to be super, super simple. And the real power here is in the loop and the condition. Okay. So if I can do this with files, right, like I can do all sorts of things. What if I've got, let's see. Well, what if I have a much more complex file? Let's do this for a little bit. So I'm going to look at shoedata.txt. So this here is a file with 100 lines in it. So, oops, come back. Here we go. Shoedata.txt contains 100 lines, and each line contains 3 fields: a brand, a color, and a size. By the way, these are not clown shoes, these are European sizes. Although, with some of these color choices, maybe they should be clown shoes. In any event, so basically the idea is, I'm going to just give this to you as an exercise right now. All right? So I want you, I'll mark it as such. We're going to say shoe dicts. What I want you to do is use a list comprehension to turn this file into a list of dictionaries. Each line should be turned into a dict whose keys are brand, color, and size. And the values can remain strings. Don't worry about the sizes. So here, I recommend that you write an external function that takes a string as input and returns a dict, and then invoke that in your comprehension. Okay, and so the result will be a list of, it'll be like this. Just do this like this. It'll be like, brand, Adidas, I don't know, like color, black. I don't know what I actually have there in the file. Oops. And then like size, 45, something like that. And then we'll just have a whole bunch of those. All right, so see what you can do with that. This is going to take a few minutes, I recognize that. And this is to show you that you can really start to do very, very, very sophisticated things in terms of data manipulation with these pieces. By the way, this is a good way to get friendly with people at Python also. I should have mentioned this at the beginning. It is always best if two people work on one computer. Programmers hate that, hate it, because they're like, no, I'm going to struggle through this myself. But if you're sitting next to someone you know or would like to know, definitely like talking it over, trying to do it is always good. Oh, I'm sorry, I thought I mentioned this before, but I'm looking it over now, I didn't. The fields are separated by tabs. Everyone's like, oh. All right, hopefully that doesn't mess things up too much for you. Or makes it blindingly obvious and easy. Okay, let's start to look at this together, see what we can do with it. So, first of all, let's remember, a list comprehension returns a list. I'm not trying to create a dictionary here. I'm trying to create a list of dictionaries. And so what I want to get back from my expression is one dictionary. And then when I run the list comprehension on this file, I'll want to get a whole lot of dictionaries, a list of dictionaries. So I can start off by saying like one line, for one line in open, shoe data.txt. And it looks like a horrible mess. Fine. But now what am I going to do with it? Well, I can say one line dot split on tab. And that looks pretty good already. And I want to turn these, though, into a dictionary. And here, could I do it in one line? Yes. Is it a good idea? I think not so much. So I'm going to split this off here. I'm going to say here, like, let's do this, def line to dict, okay, one line. And say here, return this. Say line to dict of one line. So what's happening here? Nothing. Nothing has changed. Right? What I've done now is I've simply shifted that functionality from this line here to the function here. But really, it's doing exactly the same thing. However, now I have a little more sort of room to play with things. So, a simple, not working approach. All right, well, let's try to make it work a little better here. So I'm going to scroll down. Okay, so what if I get it, a simple working approach? That's always better. Working is better than not working. I mean, less for the computer. So what am I going to do? Well, I can say here, like return, I can say fields equals that. And then I'm going to say here, return a dictionary. I'm going to say here, like brand, field 0, and color, fields 1, and size, fields 2. And what do you know? I get a list of dictionaries back. Pretty snazzy, I'd say, for very, very little code. Right? Now, I can do this even better. I can shrink my function down quite a bit more. We'll do one thing. I'm not going to go the whole distance here because we have other things to cover. But basically, I could, for example, a little better using what's it called? Unpacking, where I can say here, brand, color, size, and then I can say here, brand, color, size. Right? And then I get the same thing. It's just, I think, a little more readable. Because split, actually, there's still a little bug in there, which is the new line. Get rid of that new line. Grr. There we go. So basically, what's happening here? Well, we're going through our file one line at a time. For each line, we're invoking the function. The function gets called. It says, I'm going to take this line, remove the white space on either side, here being the new line. I'm going to split that across tabs, and we know that there should be 3 elements. Those 3 elements are assigned in parallel to brand, color, and size, and then we return a new dictionary based on it. So if I had 1,000 shoes in there, then we would have a list of 1,000 shoes, right? There are only 100 here, so poor thing. Okay. Questions or comments about this? Yeah, please. No, I didn't use from keys. I could. Yeah, absolutely. I could use from keys. I could use zip. There are a few different ways we can sort of play this. Yeah, absolutely. Other questions? Okay. So basically, we see here that I can I can write a function, I can work on files, and really the moment that you have that mindset of, right, I have this iterable, I want to get this sort of result, and I know how to map from the first to the second, a world of possibilities opens up. Okay. Let me show you one other fun example of what we can do with this sort of thing. Just double check what files I have here. Excellent. That's what I hope. Okay. So I have here, by the way, those of you not familiar with this in Jupyter, you can, not very helpful. You can run a command line program with exclamation point. So I'm just ls I didn't need to, but here. So I'm just looking at the top of mini access log. That's this file that I have. I think it's 100, 200 lines that are from an Apache log file from years and years ago. When is it from? 2010, which back then seemed very modern and fancy, but now we know it was not. So basically, what do I want to do with this file? Well, what I might want to do is I want to retrieve all of the IP addresses from mini access log. Okay, sounds pretty good. And this is very, very similar to what we did before with etc password. So I can say here, one line, for one line in open, mini access log. And I get a list of the whole file. I don't want everything, though. And this is, by the way, where I always like to say, know your data. Right? If I can look at this and say, well, the IP address is at the start of the line, and it comes before any white space, who cares about the rest of the line? Right? I'm just going to do a split here and grab the first thing. I don't need to really parse the whole line just to get this to work. And there we go. Now I have the IP addresses. Well, now what? Well, first of all, it might be useful to have, but what if I want to know how many times each IP address accessed my server? And for this, I'm going to reach into the standard library and pull out the counter class. Counter is amazing. And I used it wrong for years, luckily before I started teaching, right? So I would say from collections, import counter. And then I would say the bad, wrong way to use counter is as a cheap default dict. Right, so I would say C equals a counter. Then I'd say C of A plus equal 5 and C of B plus equal 3 and so on and so forth. And it's happy to do that. But this is not what it was designed to do. Right? The real way to use counter is to initialize it with an iterable. And so it will count how many times each element of that iterable is there. And so then each element becomes the keys, or becomes a key, and the number of times becomes the value. In other words, if I now say counter of one line split 0 for one line in open mini access log, I think I got something wrong there, it now tells me how often each of these IP addresses access my system. Not too shabby for 2 lines of code. And of course, if I want to, I can assign this counter to a variable, and then I can run methods on that variable. For example, so counter has inherits from dict. So I could do like for key value in c.items, print key value. And now I have, right, I've printed out basically what I did before. But let's say your boss has asked you to create something based on this. And your boss, it's been a while since they did tough math. So you want to give them something graphical. So you can give them a little histogram. Right? Because you can multiply integers by strings in Python. Oh, but wait, it doesn't start from the even space there. So fine. So I'll do colon 18. There we go. So with very, very little code, thanks to comprehensions and thanks to counter working together, I can produce all sorts of reports like this. I can also call special methods on counter. So I can say c.mostCommon. And then this is a counter method that returns a list of tuples from the most common to the least based on the counter. And so now, if I can just sort of grab those and print them out. Or, of course, I can invoke most common with an argument. And then I get only that many elements in the output list. So I say C most common 5. And I get only the 5 most common there. So comprehensions are pretty amazing, but when you mix them together with other things that we do in Python, like counter in the standard library, then it's almost like magical. Questions or comments so far? Oh, yeah, please. Sorry.
Just scroll back up.
Absolutely, absolutely. Here? Yeah. Absolutely. Right, and what you can see here also is very often I'll just pass a list comprehension, not exactly passing a list comprehension. I'm putting a comprehension in a function's, as a function's argument, knowing that the comprehension is going to run first, and its list, whatever it produces, will then be passed as the argument to the function. I'm not interested in storing in a variable somewhere. I don't have to do that. I can just put it there in the parentheses and do its thing. Okay. So let's see. Let me just check one more thing here. Fine, we'll do that later. Okay, so we've basically seen a whole lot of stuff that we can do with our list comprehensions. I'm just looking at the time also because we have 10 minutes until the break. Does anyone know how long the break is supposed to be, by the way? I heard 10 minutes, I heard 30 minutes. 15! Okay, there we go. Someone actually is knowledgeable about this stuff. It's certainly not me. Excellent. All right, so let's see. So we've now seen what we can do with list comprehensions. We use them all over the place. And the same rules apply for list comprehensions as for lists in general. So you can't put it in, because lists are unhashable and can't be used as dictionary keys, you can't put a list comprehension where you would use a dict key or something else of that sort that would be hashable. But otherwise, anywhere you can put a list, you can put it. That's really terrific. Okay. This is all very nice and everything, but we can do better than this also. Because let's say, I'm going to go back to my usernames. I'm going to say usernames equals, say one line split on colon 0 for one line in open Linux etc password txt if colon in one line. And sure enough, I now look at usernames and I have them. And now that I have them in a list, of course, I can search for them, right? So we can now search for usernames in this list using in. So I can say, root in usernames. The answer is yes. Is Reuven in usernames? Yes. Is blah, 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 blah in usernames? Probably not. No. Okay. So the good news is that this works. The bad news, though, is that I'm searching in a list. And searching in a list takes linear time, by definition, right? Because we have to step through, how is in working behind the scenes? In runs a for loop behind the scenes and goes element by element by element through each thing that we have in the list until it either finds it and says true, or it does not find it and goes to the end and it returns false. So if I'm going to be searching a lot through my usernames, then maybe I should use a different data structure. Right? Well, what else would I use? What searches faster? And the answer is a set. Right? Sets, basically, for those of you not super familiar with them, so sets are basically the keys of a dictionary. So they're guaranteed to be unique, and they're hashable, and thus they're searchable in very short amounts of time. So that's, guarantee uniqueness in their members. Oops. Searching is very fast, and all elements are hashable, just like dict keys. Right? You can think of a set really as a dictionary without values, right? But, okay, well, how does that help me here? Well, what I can do is, I can go up here, I can take my list, and as soon as I get it back, I can say here, set of this thing. And so now, what is the type of usernames? It's a set. Well, we can do better than that. We can use a set comprehension. And a set comprehension, it looks almost exactly like a list comprehension, but it uses curly braces instead. And so basically, yes, it's true, I could do this, but think of what I'm doing in this example here. In this example, I'm first creating a list, and then I'm passing that list to set, and set is then creating the set for. And here, if I just use the curly braces, it's a little neater and nicer, and I have to assume a little faster. Maybe we'll check that in just a moment. Oh, I should get rid of the square bracket there. And now the type of usernames is set. And now if I search in here, root in usernames, here, see how much faster that was? Right, so basically, I can create a set really, really, really easily just by swapping the braces. Right, if I used to have square brackets, now I use curly braces. Now you have to remember, this is a set, which means the elements must be unique. If you had non-unique elements before, some of them might disappear on you. This can be surprising if you're not expecting it. So let's do a quick little exercise before the break. So let's do some unique numbers. So I want you to ask the user to enter numbers separated by white space and print their sum, but only count each number once. So as an example, if I say here, enter numbers, I say 10, 20, 30, 10, 20, 30, it'll say, total is 60, which is a little bit of a lie, right? It's actually 120, but we've only counted each number once. All right, so what am I going to do here? Well, I could say now, s equals input, enter numbers, strip, and then I'll say here, I want to do sum of, say, int one item for one item in s split. And this is going to be fine if I say 10, 20, 30, 10, 20, 30, but it's going to add up to 120, because here I've got a list. So I just do a little switcheroo with the parentheses, and now 10, 20, 30, 10, 20, 30, and because it got a set, it narrowed that down. It deduplicated them. Questions, comments so far? All right, so we're going to take a break now. I can tell you, so I live in Israel. People in Israel never let me talk so long without questions. So the good news is that if you have more questions, don't be embarrassed. You can keep asking them, ask even more. The other piece of good news is I will be able to throw in some extra stuff at the end because we're clearly going to have more time because you guys are not as loudmouthed as the people back home. So I'll be able to go deeper into some things, which should be a lot of fun. All right, so let's go to the break, and we'll be back here, I guess, 15 minutes? Sure, we'll find out what the official line is. Okay. By the way, you don't need it just yet. As part of sort of time adjustments that I'm doing, cultural time adjustments. So I've added some files to the GitHub repo here so that we'll have some more things to play with later on the course. I'll also make that available to you. I'll tell you where you can get it from. So don't worry, none of the files are bigger than 10 gigs, so it should be downloadable pretty fast. No, it's like really, really ridiculously small, don't worry. Okay, so what we saw here just before the break was that we can do a quick little switch of the parentheses, and just as we can define lists with square brackets and we can define sets with curly braces, we can create list comprehensions with square brackets and and set comprehensions with curly braces. And set comprehensions are really, really useful. And it's true that in this example, I used it for uniquifying, for deduplicating the data. Definitely useful for that in a lot of different places. What I showed you before was when we loaded up the usernames, we can create a set based on that, and that's great, not because it works faster, because it doesn't. There is that overhead associated with the hashing function that it'll take longer to set up the set. But once you've set it up, then searching it is much, much faster than searching in a list, which is fantastic. So if you're going to be searching in your usernames once, it is not worth creating a set comprehension. But if you're going to be searching in it a lot, 100% worth it. And so you can use this basically whenever you have sort of the question, how many unique blah, 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 how many different blah, 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 like whatever the thing is that you're looking for, different, unique values, you almost certainly will benefit from using a set. And if you're getting it from some sort of data source that's iterable, then using a set comprehension can also be really, really great. So let's do a slightly longer, more complex exercise now. We're going to go back to our password file. Let's see, password. So again, those of you who don't know, about Unix and so forth, that is not a requirement for this class or even for this exercise. But so far, we have been concentrating on the left side of this file. We've been looking at the usernames. Well, the different fields that we have in each line, in each valid line here in etc password are we have the username, the not password, it's jumping around a little, the user ID, the group ID, then we have the, it's the username. Wait, anyway, user group, group I guess. Anyway, no, it's just the name, It's like fooling me because these are the system things. And then basically we've got the home directory, and then we have the shell. And the shell is the command interpreter that's used in Unix, right? So you might use bash or zsh or, heaven forfend, tcsh or something, right? But you can use one of those, and you can also have the shell, the interpreter, defined to be something, as you can see here, for no login, where when someone tries to log in with that, they can't right away. And so setting the command interpreter, setting the shell in a Unix system is not an unusual thing to want to do. So what I want to do now in an exercise is, which shells? So I want you to read through Linux etc password, come back. Let's see, password txt, and find the different shells that are used on the system. Now this is in some ways the opposite of what we did before looking at counter, where counter expects to get a list where the items are not unique, and then will tell us how many there are. Here, we want to get the unique list. Not a list, but we want to get the unique. Anyway, you know what I mean. All right, so we'll give this a few minutes, then we'll look at it together. Okay, so let's look at this. So I'm going to start off actually with a list comprehension. Actually, let me not do that, and then I'll show you why I do that. So what we want to do then is go through Linux etc password txt. So I'm going to start off with curly braces, and I'm going to say here one line in open, Linux etc password txt. Great, and I have a set of the lines from this file, which seems weird, right? Like, why would I want to read these in as a set? But actually, there are times when we might want to do that. And then I say, well, how am I going to want to get this data? Well, I know first of all, I'm going to add an if statement here, like looking for a colon each line. So I'll say if colon in one line. And yes, you can have the condition there in a set comprehension as well. And then I'm going to say, well, I have to break it apart. So I'm going to say one line dot split on colon. And that's where it goes wrong. And it goes wrong because split always returns a list of strings. And the set comprehension cannot have things that are not hashable. Not hashable is more or less immutable. Not really, but it's close enough for our purposes. You can't use a list as a dictionary key, and so you can't use a list as an element in a set. And it's very nice that I'm just kind of trying to do this one step at a time, stepping through what I have to do in order to get the shell from each line. But Python doesn't know that. It doesn't know that I'm almost done having a list there, and so it blows up. And so that's why I will very often just use a list comprehension at first, and then later on change the braces back, and now I can sort of inspect it and see what's going on. I should add that, yes, I use an IDE or an editor of some sort, and I use all sorts of fancier tools for developing, but very, very often I develop in Jupyter, especially with something small. I call Jupyter my laboratory for Python, because I can do lots of little experiments quickly and easily. And so I'll sometimes go back and forth between my editor and Jupyter, sort of play with things. In any event, what we see here then is I have a list of lists, right? The list on the outside from the list comprehension, and a list on the inside from split. And we can see that very similar to what we had before, where we were getting the usernames at index 0, now I'm going to want to get the shell from index, I'm just going to call it index -1 because I can't count that high. Right? Now, we'll also see that we have the \n, because when we read from a file, each iteration gives us up to and including that new line character. So it will always include the new line. So we got to get rid of that somehow. Well, that's okay. I can do just strip here. And now I have a list of all the shells in that file. And now that I have the data that I want, I can uniquify it by saying here, curly braces. And now I have a set with all the different shells in that file. And the set did the hard work for me of making sure that I don't have any duplicates here, which is pretty snazzy, I think. Right, so once again, we see that we have our three parts to comprehension. We have the expression, which here is getting somewhat complicated. We have the iteration, which is not that complicated. And then we have the condition, where we can do all sorts of things. Questions, comments, thoughts about this? Why did, say it again? Oh, I didn't start with, so why did I not start off with a set? Simply because if I'm trying to step through a whole bunch of possibilities, right? So if I know that I want to do split, and then I know I want to do something with that split, but split is going to give me a list, and lists cannot be set elements. So basically, if at any point along the way, if I start off with the curly braces for doing a set comprehension, and at some point along the way I end up with a list as the output for my expression, then it'll blow up. So starting with a list comprehension is just like a fail-safe. I know that I'll get back something that I can view and inspect, and then if I go past that list, then I'll be able to change it back to be a set comprehension. Okay. Other questions? Okay. So we can run set comprehensions on all sorts of things. And really, I've done this quite a bit. And don't forget that sets have all sorts of great operators and methods that we can use to compare them with other sets. So, I mean, it's not unusual. I've definitely done this a few times where I've had collections of information and I had to move it from one place to another. I wasn't sure sort of what had and had not moved. And so I would just slurp up each file using a set comprehension. And then I could do, subset and less than, and less than is subset, and subtraction, all that other good stuff to actually make it work. Okay, well, let's get more complicated. So what if I have, a string, and I want to create a string, with some words, and I want to create a dictionary where each word is the key, and the word length is the value. Okay, sounds like a really exciting dictionary. Okay, maybe not. So basically, how would I do this? So if I say S equals, this is a bunch of words. Okay? So I can turn this into a dictionary with actually a list comprehension some help. right? This is not going to be the best way to do it, but this is sort of stepping through the logic here. So I can say here, let's just scroll this up a little bit. So I can say here, one word for one word in split. Okay, so far so good. And now, instead of returning one element as my expression, I'm going to return a tuple. I'm going to return one word, comma, len of one word. And what is that going to do? It's going to return a list of tuples. Well, as you might know, right, we can invoke dict on a list of tuples and get back a dictionary. So I can say dict of this whole thing. And there we go. I've created a dictionary based on it. So could I do this? Yes, absolutely. Like, we see that I can do it. But the cool kids, right? So we could use instead a dictionary comprehension. Now I'll add dictionary comprehensions can look really, really messy, and you're going to see why in just a moment. So how do I translate this? Well, first of all, what kind of braces are we going to use on dictionary comprehensions? Curly braces, just like with set comprehensions. And at first that seems really weird, but it's okay because we use curly braces in general in Python for both dictionaries and sets. So how does Python distinguish between those use cases? Well, in a dictionary we have colons between the keys and values, and in a set we don't. So basically Python looks for colons in there. If they're colons, dictionary. No colons, set. The same thing is going to be true here. So we use curly braces just as with a set comprehension. But we have two expressions in the first line separated by a colon. And that is weird, as you're about to see. So I'm going to say here, curly braces, and I'm going to purposely put in a lot of extra white space so it can be more obvious, colon, len of one word. So this is my key value expression. And then here I'm going to say for one word in split. That doesn't change, and I'll have my closing thing there. And it works. It definitely does work. But, right? Like, you have this expression and you have that expression, and they are independent of one another. And that is really annoying in a whole bunch of cases. Now, we will see how we can clean that up, but it's going to have consequences, folks. Right? It's going to clean it in some ways and look ugly in other ways. That's the way it is. So basically, a dictionary comprehension is going to have two expressions separated by a colon. That also means, by the way, can you use a function with a dictionary comprehension? The answer is yes. But if you're using that function, it's going to return either a value for the key or a value for the value. It can't do both. Right? Like, you could normally say, but a function can return a tuple. Yeah, it can, but it can't return a colon, right? The colon is a syntactic element here that we just can't get around. And that's the sort of annoying thing with these sorts of things. Let me see if I have it here. If not, I'll just create it really quickly. Do I have? No. All right. So I'm going to create a really fast config file, right, with name equals value on each line. So I'm going to say with open my config.txt for writing as out file. I'm going to say here for one key. Let's do this. I'll say here index one key. Let's say one character. In, we'll say here enumerate of, let's say A, B, C, D. We'll start with one. We'll say here out file write. And on each line, I'm going to say here one character equals index. New line. Okay, and now if I look at my config.txt, look at that. Fantastic. I've got a configuration file written to perfection. It just doesn't really configure anything useful. And by the way, I love this kind of code in Python where we're opening the file for writing within a with, so we know that it's going to be flushed and closed. I give it an alias there, out file, and then I iterate over that string using enumerate, and enumerate, when we iterate over it, gives us two things, the index and the character. So it's going to go through A, B, C, D, but we're going to get 1A, 2B, 3C, 4D. And the reason it starts with 1, not with 0, is because they're told to do that. And I'm just going to write to the file these lines using an F string there. So I've got my file. So I can use a dict comprehension to read this file into a dict. I can say here, well, what am I going to do? we're going to say for one line in open, what's it called, my config.txt. And then what is going to be the key? Yeah, it's going to be one line split on equals 0. What's going to be the value? One line split on equals 1. Oh, no, it's not. We also have to have a strip in there. Beautiful, right? This is why people say Python code is always so elegant. Okay, maybe not so much here. But you can see that it worked, that I was able to, with this dict comprehension, read this configuration file into a dictionary very, very easily. And so we see here really that, again, the sort of power of these comprehensions. Okay? Questions, comments until here, and then we'll practice this a little bit. Yeah, please. Oh, I flip a coin, a virtual one, yeah, right? So here's the thing. You can run strip on a string. So you can either do it before you do the splitting up of stuff or after you've got one element. A very common mistake that I see people make is they do split and then they try to do strip and it blows up because strip is not a list method. But I am extremely inconsistent in when I do it, and probably at some point I should check to see which is faster, and if there's any real difference, then I should make a decision. But yeah, I probably should do that at some point. Other questions? Yeah, please.
The with syntax for opening files is really nice. Do you know is it equivalent here? Like, does the file get closed nicely inside of this thing? I have no idea.
So probably, sort of, kind of. So the way that it works is, so with explicitly, like if and I'll just scroll up back here. Can I scroll there? So with is what we call a context manager, and it basically hides two method calls in here. Here it calls outfile.enter, and here it's calling outfile.exit. And basically, like, these are hidden methods, magic methods, and enter actually does nothing here, although it could theoretically do something, and exit says, I want to flush and close the file. So this guarantees that by the end of the with block, the file is definitely flushed and closed, and when you're writing to a file, this is important, because if you don't flush and close it, it might be a very long time. It will eventually get closed, and it will eventually get flushed, but like, it might be when Python shuts down, which will be like, for me, at the end of this session, which is kind of sad. So with is like, I know when I want it to happen. I, first of all, don't get too worried about it when I read from a file. Whatever, I'm opening a file for reading. I know that makes me like, you know, a bad guy in the Python world in some places. I'll take him on. It's okay. No, like, I mean, if you're working with lots and lots of files, that can be a problem. If you're working with Windows, I'm told that Windows doesn't like it if two people try to read from the same file at the same time. But like, generally speaking, I don't care that much in these sorts of situations, in part also because, and we are going to have time to look at this, what I mentioned earlier, comprehensions open a new scope. And so what's going to happen is when the comprehension returns, that scope disappears, and so the odds of still having a reference to that file object are very slim, and so I think the file is going to be almost certainly closed right away. It's not guaranteed, but it's so close that, like, who cares? Also, you can't put with inside of a comprehension, so there. Yeah, please. So generally speaking, any variables that you are assigning to inside, not modifying, but assignments to variables inside of a comprehension, which really only occurs in one place. It really only occurs here in the for loop, right? So that variable is internal, local, has nothing to do with anything outside of the comprehension, which is, and again, we'll see this a little bit, because I'm excited that we'll have time to do this, is in stark contrast to for loops. Right, and it was something new that they put in Python 3, which is not so new anymore, but like, I'm old. But like, basically, I remember it was very surprising, and when I sort of dug into it, it was kind of cool to see what they did there. Other questions? Okay. So here's what I want to do. Let's do a little exercise to play with dict comprehensions a little more. Let's do this. Let's do usernames and shells. Right? So what I want you to do is use a dict comprehension to create a dict in which the keys are usernames and the values are the shells associated with those usernames in Linux etc password.txt. I guess I don't need a number 1 here. That's it. All right, so I'll give you a few minutes to work on that, and then we'll look at it together. Keep forgetting that. All right, so I'm going to start off, like with the set comprehension, I'm going to start off with a list comprehension here. Again, not because I have to, but just so I can sort of get a feel for what's going on and then rejigger things as necessary. So I'm going to say here one line, for one line in open, Linux, etc, password, blah, blah, blah. We'll say if, colon, in one line. So we get our standard stuff. And then what am I going to want from there? Well, I'm going to say here one line, split on colon. I'm going to do it the tuple way first. Split 0, comma, one line split on colon. Say here -1, strip. And so now I'll get my list of tuples. Not exactly what I wanted, but pretty close. And now at least I understand what are the different components I'm going to need. Okay, and so now I can rejigger it into an actual dict comprehension. So here I'm going to copy this, and this, and this. Right, and so now I'll start with a list tuple combo. All right, and then here I'm going to say now curly braces, colon. Again, I'm exaggerating that white space, colon. And there we go, I get the same thing back. So I can start off with one and get the other one. Right, and sure enough, I now have this dictionary in which the usernames are keys and the shells are values, and it's going to work great. Okay? Questions? Yes, please.
For iterables with a large number of elements, what's the implication of having to call split twice?
Yeah, great question. Could be worse. Right? Like, split is at least written in C, part of the standard library, it's running on a string, like, but your point is a good one. And it does really, like, even someone like me, I mean, I'm a dynamic language kind of guy. There's a reason I'm in Python. I'm like, oh, please, like, I'm paid by the hour. I'm a consultant. If it takes longer, all the better. But there are times when I actually do want things to run faster, and this just, like, sort of haunts me a little bit. So maybe I could improve this a little bit. And the question is how? Like, it would be really nice if I could split it once and then use it twice. But as I said before, those two parts of the expression are distinct. They can't, like, carry over. But, what gets executed before the expression in the top line? Well, the for loop and the if. What if I could somehow take advantage of that and have it carry over? I'm glad you are all sitting down. I hope you also brought Tylenol. Okay, so here's the thing. This if here at the bottom, this is a condition, right? What could I possibly do there? Well, what if I made it a compound condition? What if I said, like, and something? Well, and what? I mean, I could say, like, and true. What if I were to say, like, and one line split on colon? Well, it's not going to be bad. I'm going to get the same thing. It's kind of useless. Like, now I'm using split 3 times. Ka-ching! No. Like, basically, what if, though, I could somehow capture it there? What if I could put it into a variable? Like, what if I could say, like, fields equals that? Well, now Python's going to say you can't do that. You can't do that because assignment in Python is not an expression. Assignment is a statement. Oh-ho-ho. But you know what is an expression? The walrus operator, friends. And it works just great. What the heck is going on here? Well, what I said is I'm going to do a one-line split. We are going to assign it to the variable fields, and then the value of fields is going to be passed back to the if. And it worked just fine. And because it executed before our expression, I can now say field 0 and fields minus 1 dot strip. Voila, it works. And now your colleagues will never talk to you again. So, is this better? I guess. but it does have some downsides, like you won't have any friends. So, but like, more seriously, when the walrus operator was revealed to the world, this was one of the places where people talked about using it. This and while loops, where basically, we don't just want to do while true and then check something inside, but we want to maybe do something a little more active. And I must say, I am consistently, ambivalent about this. I want to like it. It's really kind of a cool use of things. And yet, it seems more like an abuse rather than use. But at least I'm not calling split multiple times, right? Like, big win. So there's that. Any other questions to tempt fate? Yes, so it's a colon before an equal, and one of the saving graces for the walrus operator is that you cannot use it where you use a regular assignment. So if you just try to say like x colon equals 5, it won't work for you. Now, the walrus is introduced in, I want to say, 3.8. So if you're using a version of Python before that, then it won't work at all. If you're getting errors and you're after 3.8, then it might just be like so. I'll tell you the other thing I did is I put parentheses around this assignment here. Because if you don't do that, I think I just like do it instinctively now. Yeah. So what happens is, if you don't put the parentheses there, making that whole assignment split business one expression, then it's like if colon in one line and fields. Like, and this then like is hanging off the edge, and Python's parser isn't sure what to do with it. So you just have to put the parentheses in there. Yeah, please. So right, if somehow fields were false, then that's right. Then the if would not. Then we would not run that top expression. That's exactly right. But fields is going to be a list, and lists are only false when they're empty. So I'm basically betting here that there's a colon in the string, and so when we do the split, I'm going to get more than one thing. But you're right, there might be some weirdo corner case there. Yeah, please. Oh, I'm sure. The question was, could it backfire somehow? And I'm sure there is. I can't think of it offhand. I think the real backfiring, like, look, you might or might not know this, but like when the walrus was approved, there was like a firestorm in the Python community of like, what? What craziness? How could such a thing, like, and so like, it was a really, really, really big deal. Like, you think Python people are all nice and calm and reasonable, yet introduce a walrus into the language and like the big teeth come out, all meanings aside. So I'm sure that there's some like weirdness, backfiring problem that could show up here. That said, it is convenient in this sort of situation. Like, there are times when I'm going to want to do this. Other questions or thoughts about this? Or total revulsion? All right. So we've now seen a whole bunch of, we've seen now mostly the whole gamut, most of the gamut of the comprehensions that exist. The normal comprehensions, list, set, dict comprehensions. And it's hard to exaggerate how often we use these. I would say list comprehensions are more common than set are more common than dict, but it probably like depends on your usage. But very, very, very often, if I have, like, and the rule of thumb definitely has to be, I have an iterable, I want an iterable of some sort. I want a list or set or dict, and I have some way of mapping between the old one and the new one. If you can fulfill those three requirements, then a comprehension is probably going to be faster, more compact, and idiomatic in Python. It doesn't mean that you should not ever use a for loop, but those are the situations in which you should try to use it. Okay, but we can do even more than that. Why stop there? So let's say I have a list. My list equals, I'm going to create now a list of lists where inner lists have, contain integers. So I'm going to say my list is, we're going to say here like 10, 20, 25. This is going to be very exciting, people. I'm going to say here like this is going to be 30, 35, 40, 45, 50. I'm going to say here, 60, 70, 80, 90, 100. Let's just do one more. 110, 115, 120, 130, 140, 145. Okay, I think that's good enough. Okay, so we have here a list of lists. How can I sum the integers in this nested list? And the first thing you might say, first guess, is sum. Bad guess. So I say sum of my list, and it completely falls apart right out of the gate. Why? Because once again, it starts off with a total of 0, and it goes through my list. Well, what is the first element of my list? It's a list. So it tries to add 0 plus 10, 20, 25, right? And it says then, I can't do that. I can't add an int and a list together. So this is already not doing so well. But maybe I could use a comprehension to do something with this, right? Maybe, because we are in a comprehension tutorial, right? So, guess 2, use a comprehension. So what if I say one sublist for one sublist in my list, and I do a sum on that? Actually, that's going to be just as bad because it is equivalent. Because what is the result of this list comprehension? It's exactly the same thing as we had before. I mean, look at it. I'm going through my list, I'm getting one sublist, and I'm returning it. I've copied my list, basically. And now we're sort of running into that brick wall that I described earlier, that the number of elements that we get back is either the same as the input, or, thanks to if, it can be lower. But how can I get more things back? Right, because that's what I want to do here. I want to have an input of 4 elements, but I want to have output of, let's call it more than 4, because I can't count that fast. And now it's time for nested list comprehensions, where I'm going to say one number for one sublist in my list for one number in one sublist. Ta-da! I've got them all out one at a time. Now, we're going to go over this, don't you worry. Or worry. And it works. So what the heck is going on here? So basically, as before, we have our for loop, for one sublist in my list. But we don't yet go up to the expression. We then, in the middle of this for loop, right, for each iteration of this for loop, we then do this for loop. And any variables that we defined here, for example, one sublist, are available here. And any variables from both of these are available up here. So basically, I'm able to take a complex data structure, in this case a list of lists, and break it apart into little pieces so that I can then extract one piece of it. Now, if I wanted to, right, because everything is available everywhere, I could do something like, one sublist, one number, right? And now I have a tuple in each element of the sublist the number came from and the number itself. A little weird, but there's nothing technically wrong with it. Oops, let's get that. Oh, come back. There we go. So how does this work? Again, we have our regular list comprehension with our regular for loop. We then said, but wait, the thing that I got in each iteration, it is also iterable. So it has to be an iterable of iterables for this to work. And then I can iterate over both, and then I will get output not for each main item, but rather for each sub-item. Now, nested list comprehensions, if you think list comprehensions confuse people, nested list comprehensions completely and utterly bamboozle people. And it's like, why? I think a big part of it is how they're written. Traditionally, they are written like this. Gee, that's super understandable, right? Like, I didn't understand these for years because which for goes with which in is evaluated when. And the moment that I started writing them, I mean, it works, but the moment I started writing them on multiple lines, it suddenly became like crystal clear to me. Because it's also going in order. First the first for, then the second for, and if you're daring, the third for. Like, you can go as many as you want. Don't, but you can. But wait a second. Oh yeah, please. So the question is, can we use if statements there? And the answer is, absolutely we can. Let's do that. So I'm going to grab this. So I can put an if statement after any of the fors that I want. So I can say here, if len of one sublist is greater than 3, and then it will only drop down to the second for loop if it is greater than 3. But I can also put an if statement after the second for, and that'll be evaluated there. If one number, let's say modulo 2, meaning, only if it's odd. So this is going to give me, only long sublists. So this is going to give me odd numbers from long sublists. And you can imagine that this could be way, way, way more complex than that. Now, an interesting little outgrowth of this, excuse me just a second. Ooh. An interesting little outgrowth of this is that you can always, in all list comprehensions, regardless of how many fors you can have multiple ifs. You can have multiple if lines, and they're just ANDed together. So I can say here, for example, let's do this, like, numbers equals 10, 20, 30, 40, 50, 60, 70, I don't know. Let's do this actually, let's do 35 and 55. And then I'll say here, one number, excuse me, for one number, in numbers. And I can say here, if one number is greater than 40, and if one number modulo 2. I don't have to say and, because the structure of these nested list comprehensions always allows me to have multiple ifs. And if I have more than one if and only one for, that's okay. That actually will work. And so I think I figured this out like a few years ago. I mean, when I say I figured it out, like, I'm sure other people had figured this out before me, but I had this revelation. I was like, oh, wow, this is really useful. Instead of having a really long line of if this and this and this, I can just have multiple ifs and it'll work the same way, and I think it's just cleaner. So I'm not going to tell you that nested list comprehensions are something you're going to do every week. Probably not. I hope not. But when you have a complex data structure, it can be really, really helpful to unpack it using this sort of nested list comprehension. It really comes in handy. Again, not always, but often. Okay? And by the way, you can use nested set comprehensions and nested dict comprehensions as well. But I will let you do crazy things like that on your own time. That said, I do want to practice this a little bit, play with it a little bit. There's a file that I use for this kind of exercise, which I did not include in the download. I put it on the GitHub repo here, so you can download from there if you want. Also, if you go to files.lerner.co.il, it's under advanced Python. It's that zip file, and there is some overlap between the two. All right, so I'm just going to stick this here. And so, download the, which file is it? Oh yeah, it's movies.dat file from here. And so movies.dat, it's just a CSV file, like with colon between the elements. This is like a long list of movies from a movie rating system from years ago. That's like not at all the important thing. And what you see here is we see that each line in this file contains a record describing one movie. And the fields are separated with double colons. The first field is the ID number. The second field is the movie name and its year. We're going to ignore both of those. The third field is a set of, or vertical bar set of, separated set of genres, like movie genres. And so basically, here's what I want you to do for an exercise. Exercise like movie genres. So I want you to use let's just do this. The goal is find out what the 5 most popular movie genres are in movies.dat. Okay, and so what I want you to do is use a nested comprehension to read through the file, find the appropriate fields and lines, and then use counter to find the most common genres. And so if a movie has more than one genre, right, each should be counted once. Okay? So you're basically, here's a big hint. You'll want to hand counter a list of genres from the file. There we go. I've given away the store now. All right? So I'll give you a few minutes to work on this, and then we'll look at this together. Okay. Let's look at this and see what we can do with it. So this is, by the way, complicated, right? So if you didn't get it, or you're scratching your head, or scratching your eyes out, this is complex, especially since we just started with comprehensions today. But let's start off with the simple thing. One line for one line in open, movies.dat. And sure enough, I get the lines there. Okay, so far so good. Well, I don't really want those lines, right? What I'm really going to want is in the end one genre. Okay? Or if you want to be one category, if you want to be less fancy about it. But okay, so one line, that's good. But now what? I've got that line. But what I want to do is break that line apart. So what I can say is for one genre in one line, then what? Well, I can split it on double colon. What is that going to give me? That's going to give me a list of strings. And I know that I want the thing at index -1, or if you prefer, index 2. What if I just do that? What happened there? Well, as someone said to me so many years ago, computers don't do what you want, they do what you tell them. And what I did here was I iterated over each character in each of the genres. So, a little premature maybe to be producing some results here. But what I can do is I can say, okay, one line split 2, and then I can do a split on vertical bar. Look at that. Now what I've done is I've said, throw out the first 2 fields on each line. Take the third field on that line and split that, giving me a list of strings. And then one genre is going to go over each of those. Now, it is true that I have now this \n there. So I'm going to say one line strip split, and then we get rid of that. I now have a list of all the genres that are in this file, and now I can just count them up. I can say here, C equals a counter of this thing, and then I can say C dot most common 5. And now we have the most common genres in this whole file. Now, I'm not saying it's necessarily easy or intuitive to come up with this, and I'm not saying it's easy or intuitive to read it either until you've gotten some practice with it. But it is definitely possible. And after a while, you start to think in this way. I don't know if that's good, but you can, right? But you can start to really think this way and then really play with it, and suddenly all these file formats and files and data structures are infinitely malleable using comprehensions. All right. Questions, comments, thoughts about this? Other than, why me? Oh yeah, please, please, sorry. Oh, I think it's just like hiding off to the side there. Hold on, I'll see if I can get it a little closer. Yeah, here we go. Oops, that was bad. There we go. Okay, sure. Oh, that's a new feature in Python. You don't need to close parentheses. It just like intuits from what you want. It's part of the all new implicit is better than explicit approach to Python. All right, I want to show you one more kind of comprehension, which is sort of kind of a comprehension, and then I think we'll have a few minutes to be able to go into the innards of things as well, which should be fun. So, everything we've done so far is fine and good, and really, it really is good, but one of the problems you can end up with, I mentioned this a little bit earlier when we were talking about reading from files. Let's say I want to use a list comprehension to read from a file, and I want to get usernames, error information, IP addresses, you name it. And it's a really, really big file. Well, what's going to happen then is that the comprehension is going to return a really, really, really big list. It could be, right, because we're iterating over the file one line at a time, the size of the file is not going to be a problem because we're only reading one line at a time. But the total list that we're going to create will be too big or just will be enormous. And so what if we want to avoid that? So we can use what's called a generator expression, or sometimes people call it generator comprehension because, like, why not? And so let me reiterate sort of what we've done. Or actually, I don't have to. So people often try this. They're like, well, if I have regular square brackets and I get a list comprehension, which produces a list, and I have curly braces, which is a set comprehension, which produces a set, and then I have curly braces and colon, which is a dict comprehension, which produces a dictionary. What if I use regular round parentheses? Right? What if I say here, like, x to the second power for one number in, let's call it range 10. Will I get a tuple? And the answer is, of course, no. This is a generator. And that is surprising to people. So, first of all, what's a generator? And basically, a generator is an object in Python that knows how to behave inside of a for loop because it is iterable. Okay, and so what? The point of a generator is that it doesn't return all of its elements, at once. Rather, it only returns one at a time. And this is key to understanding a lot of things in Python. Again, when I iterate over a file, I'm not getting the entire file into memory at once, because that could be catastrophically bad. Rather, I'm getting one line, and the next line, and the next line, and the next line. So the maximum memory I'm using is only one line's worth of memory. And so I can read a 10 terabyte file without any trouble, even in a tiny little computer, because I'm only using one line of memory at a time. And that's because file objects are iterable, and they act sort of kind of like generators. So we can do that ourselves with generators, and there are multiple ways for us to create generators in Python. We can use generator functions, for example. But if you want something quick and dirty, you can use a generator expression, which looks like a comprehension and acts like a comprehension, except that it doesn't return everything at once. Right? So come back. Right? So a generator expression works just like a list comprehension, except that instead of returning a list with all of its elements, it returns a generator object. And that object can be put into a for loop or any other iterable context. And it will only run the expression once, sort of like when it is asked to, typically once per iteration. So what if I were to do this here, right? What if I say here, let's just grab this thing. So if I say here, like, G is this. And so now I can say for one item in G, print one item. And what's going to happen? The for loop is going to say to G, are you iterable? The answer is yes. It's going to say, okay, give me your next thing. G is like, okay. G says, G, all right. And it then runs one iteration here. It returns one number, and then it goes to sleep. It stops. And it waits for the for loop, then sort of whoever's on top of it, to ask for the next thing. Now, typically, we do this in a for loop, but behind the scenes, there's a whole mechanism where Python is saying, give me your next thing, give me your next thing, give me your next thing, and it's lazy evaluating. It's not doing everything at once. And that's terrific in all sorts of contexts. I don't want to get everything at once a lot of times. One of the big changes, again, talking like ancient history, I guess, one of the big changes between Python 2 and Python 3 is that Python 2 would return lists for just about everything. And in Python 3, they were like, wait, actually, that's not a good idea. Because for small things, who cares? But for big things, everyone cares. And so now, in Python, virtually anything that returns a bunch of values is going to return an iterable, a generator object, something like that, so that it doesn't potentially overwhelm our memory. And so we can do that too now. So where would I use this sort of thing? Well, let's say, oh, fine. Why did it say that? Oh, because I didn't actually, huh? Oh, I didn't want to. Oh, thank you. That would do it. Oh, instead of X, I get it. Yeah, there we go. I was like, what's he complaining about one item? It looks okay to me. There's a pro tip for you. Look at the code that has the problem, not the code that works. All right. So what if I do this sort of thing? What if I say here, and by the way, you can do like nested for loops and generators and so forth. Yeah, what if I do something like this? Well, I could even do something infinitely large. Well, let's not go crazy here. Right, so let's even do something super simple. So if I say like, my list equals, we did this before, 10, 20, 30. And then I say here, right, star join of, and then I can say a list comprehension, stir of one item, for one item in my list. This works. And I can also instead use regular round parentheses here. Right, so here I'm going to use a list comprehension. And here I'm going to use a generator expression. Now, we don't see much of a difference here. I mean, there is no difference. And the whole point is that you will get exactly the same results back. However, in many, many cases, not here, by the way, but in many cases, it'll use much less memory because it's only using one element at a time. Okay. That's nice, but it gets even better. What if I do this? What if I say here, generator expression, with only one set of parentheses? And it's the same thing. Basically, you can put what looks like a list comprehension, what is a generator expression, inside of parentheses, inside of a function call, and Python knows that it's a generator expression, it's totally okay with that. And this, by the way, when I finally figured this out, a whole lot of code that I'd seen started to make sense. I was like, I don't understand. Why are people like passing something that looks like a comprehension? Oh, it's just because the extra parentheses look kind of dumb. And so if you only have one set there, you sort of get away with them doing double duty. But yeah, it works really, really well. So if you're reading data from a file, right? So let's say I want to do something, let's do something a little more sort of interesting. So let's read words from a file. So do I have a file here? I don't have anything super exciting. Fine, I'll just read from, I don't know. I'll read from wcfile.txt. I use it for another exercise, but who cares? Right, so if I'm going to say now, one word for one line in open, what did I say, wcfile.txt, and then for one word in one line split. So you see, I'm even using here a nested comprehension. So this is going to return all of the words in the file. But if that file is really, really big, if I don't want to flood my memory with everything, then instead I can use a generator expression. And now if I iterate over this, if I say for, let's just say here, G equals this. Say, for, W in G, print, well, we can say here total equals 0. And we'll say here total plus equal len of W. Right, so total, the lengths of all words. no spaces. And so that'll work fine, but the real magic here is that every time this for loop asks G for next thing, only then is it going to advance its for loops inside of here. It's not going to run them all at once and give me that whole list all at once. It's going to save me memory. And so generator expressions have become really, really popular in Python over the last few years. I would say in the last decade, they moved from being something sort of, interesting, a little esoteric for the people who are really worried about performance, to in some cases, it's just like the default. Like, why would you use a list comprehension if in most cases, not all, most cases, a generator expression will give you the same results and will probably save you some memory? And so I just see people sort of moving in the direction of always using them. You can't always use them in place, because there are places where it's actually expecting to get a list. But if you're passing something to a function or some other sort of iterable, yeah, it works really well. The other thing that you can do with a generator expression is this. So I just mentioned you can define a generator with a generator function. And in such a function, you use yield to return a value without exiting the function. I'm not going to go into detail. Well, maybe I will, but no, probably not. So if I say def my gen, I'll say here yield 10, yield 20, and yield 30. Very exciting. Okay, and so now if I say G equals my gen, G is the generator. And if I say list of G, I'm going to get each of those. I'm going to create a list, because what happens? List goes to G, and it runs a for loop on it, and gets it one by one by one. So many people, if they want to have functions that return things in pieces, will write a generator function like this. Here's the cool thing. You can do exactly the same thing by writing a function that returns a generator expression. In other words, if I say def my gen, and I just say, let's go down here a little bit, and I say then return one number for one number in, this is kind of stupid, I know, 10, 20, 30. If I call my gen, what am I going to get back? Well, it's a regular function that's returning a generator object. And so sure enough, it works exactly the same way. So there are just some cases when I found that as easy as it can be to write a generator function, it's even easier for me to express it as a generator expression, just return that from my function or method. Okay. Questions, comments, thoughts until here? I want to stress, by the way, in the last, half hour, 45 minutes, we've been going into some more advanced stuff. Most people, most of the time, don't need that. If you came in here saying, oh, I've heard comprehensions are interesting, but I'm a little afraid about them, you're like, oh my God, all of my fears have been realized. You don't need this most days. Most people, most of the time, when they're doing comprehensions, just little list, little set, little dict, and you're done. But, for the ambitious among us, no, masochistic among us. So I just want to, I mentioned this a little bit earlier, and we have a few minutes, so I want to sort of show you, behind the scenes a little more in terms of comprehensions. And if if we just saw over the last 45 minutes or so was advanced, this is sort of super cool, brain-melting advanced. So it's on you if you don't have towels. All right. So here's the thing, and again, I mentioned this a little bit earlier. I just want to sort of make it clear. So if I say here x equals 100, and then I say for one number in, let's say, range 5, I'm going to say x equals one number times 3. What is x here? And a whole lot of people, including people who have experience with Python for many years, are like, well, clearly x will be 100. Because, the for loop couldn't possibly change what's in the, outside of it. I've got indentation. Indentation is a new scope, right? Bzzzt, wrong. Actually, we did not go into a function here. No function definition, no new scope. It's as simple as that. All of these variables here, x and one number, are all in the global scope. Okay, so far so good. So now I say x equals 100, and then I say one number times 3 for one number in range 5. Oh, I guess I need to have the x here, so fine, I'm going to say x. Well, I'll say x here, whatever. So you can see that x is like, and we'll even say print this thing, so we'll like see the result of list comprehension. So when I first discovered this, I was like, wait, what's wrong with this picture? How can it possibly be that comprehensions don't modify the outer scope? Right? Who's been lying to whom? And I sure hope it has not been me lying to all of my students. So for a little while, I would tell people, oh yeah, in Python 3, they introduced this new half scope for comprehensions. That has got to be one of the hand-waviest things I've ever told people in my courses. Because it was the only way that I could understand it, because we have the very strict rule of what's known as LEGB in Python, local, enclosing, global built-ins. There are 4 scopes, only 4 places where your variables can reside. And if you're not in a function, then the first 2 don't exist. Right? There's no function here. So if there's no function, then I must be at the global scope or at the built-in scope. And I sure as heck hope that we're not modifying built-ins. Although I did once get email from someone saying, we're having some problems at my company keeping track of our variable scoping, but we found a solution. We just say built-ins.x and built-ins.y, and everything works great. I was like, oh my God, please don't do that. Anyway, I finally decided maybe I should look into this a little more closely. Maybe I should try to figure out really what's going on here. So let's do that. I'm going to define some functions here. I'm going to say def, regular loop. And then I'm just going to copy in the code that I had before. There we go. Okay. It would help if I actually indented it. Sure. Be that way. I'm not going to run this. I don't care about running it. I care about, remember that Python is a compiled language. So when I define this function, it's compiling this into bytecodes. If I can look behind the scenes, we will see what's going on. And so I'm going to import dis. This is the disassembler for Python. And I'm going to say dis.dis of regular loop, regular lop. And what do we see here? This is what Python is actually executing behind the scenes. And what we see is it's loading the constant 100. It's store fast. Store fast is the important thing. That means local variable. So x is a local variable here. But so we're setting x to be 100, so that's local. And then we're setting other things here. It's all local. One number, store fast. One number, load fast. X, store fast. So this x and this x are exactly the same x. If before I said we're not in a function and thus everything's global, now we are in a function, everything is local. Okay, so what? Well, let's compare this with the comprehension version. So I'm going to say here, comprehension loop. I'm going to say here, x is 100, and I'm going to say here, print, I'll say x times 3. I know it's not exactly the same, but it's close enough for our purposes, for x in range 3, 5, whatever, who cares? And now I'm going to say dis.dis of comp loop. And my mind was blown when I saw this. Okay, we're loading loading constant 100, storing it in x, and then what the heck is this? We're loading the constant code object list comp. What the heck? So it turns out that when you define a list comprehension, you are creating a secret function behind the scenes. And that secret function has, like all functions, its own local variables, and they don't leak out. So if we set something in the comprehension, which we do, it won't be seen outside. It can't be seen outside. Now, the cool thing about this, one of the main cool things, is load const. So load const, so whenever you define a function, all the strings, all the integers, they are stored on the function object as constants. So if you say x equals 5, it stores 5 as a constant on the function object, and that pulls it up. So it turns out that when you have a function that has a comprehension in it, Python's like, oh, I'm going to turn this comprehension into a secret function, and then stick that as a constant on the function. And indeed then, where do I see that? Oh yeah, down here, it says, oh yeah, here's the disassembly of your code object. So this is the secret function here. And it's going to build a list. Why is it going to build a list? Because it's a list comprehension. And it's going to load fast. It's going to load a variable. It's going to iterate. It's going to store fast into X. But this X is local to our comprehension. It has nothing to do with the X that was in the outer function. And that's then why variable setting comprehensions don't leak out. Because basically they are functions in disguise. Okay. So now, like stunned silence, everyone's like, can I go home now? I'm very happy to answer further questions if you have any. Okay. Oh yeah, please, please.
You mentioned that there was a behavioral change with scoping between Python 2 and 3. Not that it really matters anymore, but there was.
So yes. So in Python 2, comprehensions were just in the normal plain old scope. They didn't do this wacky thing at all. That's why I was like what's going on here? And that's also why it has anyway. You can really spend way too much time with this, as I know. All right. So a few closing things. First of all, I hope that this was helpful, useful, interesting, and helps to put in perspective a whole lot of comprehension stuff, that you'll be less intimidated by them. You can do the intimidating now, not the comprehensions. That you'll maybe start to use them in your work, show off to your friends, and so forth. Second of all, this repo on GitHub will stick around forever, basically. So if you want to go over it, look at it, the Jupyter Notebook is there. I'll also put it into HTML format, so that if you just want to view it on your own computer or elsewhere, that's an easy thing to do. The third thing is, I love being in touch with people about this sort of stuff. I mean, that's what I do, right? So, the self-serving part, if you want me to come and do training at your company, I'm very happy to come do that. If you want to talk to me about other stuff, happy to do that as well. I'm active on Twitter, YouTube. I have a mailing list. I put that on the GitHub repo as well. And also, I'm giving some more talks here at PyCon, and I've got a booth giving out t-shirts, giving out swag, assuming it all arrives on time. So I'll be very happy to talk to you about that. And anyway, this has been super fun for me, and it's a great way to kick off PyCon. And I'm now regretting even more that last year it took me 42 hours to get to PyCon, and I missed the tutorial I was supposed to do because this was so much fun. So anyway, thanks so much, folks, and I'll see you around the rest of the conference.